So we are starting with the first topic of A levels chemistry, which is also A's level chemistry, that is atomic structure. You have studied about atomic structure quite in detail in O levels, and in A levels it's the same. Nothing has changed in its syllabus. It's identical to O levels. In your textbook, you might see the discovery of protons, the discovery of electrons using cathode ray experiment. You will see the discovery of neutrons, but these are discoveries are not in the syllabus of AS level chemistry. They are just given in your textbook for your information. They are the part of the syllabus of FSC. So if you are thinking of doing ECAT or MDCAT, तो आपको उसके लिए तैयारी करनी पड़ेगी. But for appearing in AS level exams or in A level exams in paper 1 or paper 2, the atomic structure is as simple as it is in O levels. So, sorry, it's stopped here. So atomic structure means that structure of an atom, and what are atoms made of? Atoms are made of small particles which are called protons, electrons, and neutrons. We call these particles as subatomic particles as well. You know that from the knowledge of your chemistry in O levels that these are the fundamental atomic particles. In physics, you might have studied that there are many small particles present in the atom. Most of them are very small and they are not fundamental. They do not add to their mass, they do not add to their charge. That's why we are just studying the fundamental subatomic particles and neutrinos and positrons and all these particles which are also present. We are not going to study them. So these are the three particles: protons, electrons, and neutrons, which are the subatomic particles, and they are present in an atom to make an atom. So where in atoms these subatomic particles found? This is also known to you. You can see the diagram. There's this central heavy part of an atom in which we know that all the mass of an atom is present. That is called nucleus. Why all the mass of the atom is present in the nucleus? Because protons and neutrons, which are the heaviest particles, they are present in the nucleus. And if you see, the electrons are circled around the nucleus in paths, in imaginary paths called shells or orbits. The new thing about your A-level syllabus is that these shells or orbits are now called principal quantum number. Principal quantum number is another name of shells and orbits. Up till O level, we have studied that these paths in which electrons revolve around the nucleus, these are called shells in the orbits. Yes, they are still called shells in the orbits, but they have been given another name called principal quantum number under the light of quantum mechanics and Bohr's atomic model. We have given this name to the shells. तो ये नाम भी आपको याद रखना है कि शेल्स को हम प्रिंसिपल क्वांटम नंबर कहते हैं. Principal quantum number is the new name of the shells, and in shells or orbits, electrons are revolving around the nucleus. And we know that the mass of the electron is negligible. The mass of the electron is negligible compared to the mass of proton and neutron. अभी हम देखेंगे आपको you know that from O levels that if we take the mass of proton to be 1, which is the relative atomic mass, then the neutron's mass is almost the same, 1. But the electron's mass is negligible compared to that of the mass of proton or neutron. Or we have a number which is 1 over 1840. 1840th mass of a proton, which means that 1840 electrons mass is equal to the mass of one proton. So itnay electrons are not present. These much electrons are not present in any atom. The highest number of electrons present in an atom are 116. So 116 electrons do not contribute to the mass of an atom. So all the mass of the atom is present in the nucleus, and that's why we call protons and neutrons and nucleons, and we will study that their numbers are called nucleon numbers. Yes, this is all that you have studied in O levels. One more thing is that the electrons which are revolving around the shells, these shells have very large distance between them. These shells have very large distance between them, and these spaces are empty. And it has been studied by experiment called Rutherford experiment. You don't need to learn that experiment. You just you just can have a know-how that Rutherford was a chemist or was a scientist who found out that most of the atom is empty. Most of the atom is empty, and the nucleus is so small that it is, you can compare it with a small pea size or a bean size placed in a center of a football stadium, and the whole football stadium is like an atom, and the atom's nucleus is so small that it can be compared to a pea or a bean placed in the center of the football stadium, and the rest of the place is empty. In that rest of the place, there are shells, there are paths on which electrons are evolving, and according to the Rutherford model, these all things, these all spaces are empty. The heaviest part is present in the nucleus, and nucleus is very, very small compared to the size of the atom. So according to the research, it has been proved that most of the atom is empty. Yes, electrons are present in those empty parts, but they do not affect any mass, change in mass, and they do not affect the radiations that passing through the atom. So nucleus is very small, and we call protons and neutrons as nucleons. Electrons are revolving in the atoms in areas, in paths called shells. These shells are actually not circular. These are elliptical. These are elliptical. These are elliptical, and we also come to know, we will study in coming classes, that electrons are revolving in these paths in a special wave-like pattern. So wave-like pattern is something new that you will study. Till now, electrons are in paths called shells, just like it's the solar system. Sun is in the center, and planets are orbiting around the sun. The same way, electrons are revolving or orbiting around the nucleus. So, structure of an atom, electron, it carries a charge of -1. Actually, this -1 is not the exact charge. The exact charge is given in your data booklet, and that you do not need to learn it. Maybe in physics you have studied the exact charge on an electron. So it is in coulombs. Charge is in coulombs, and the exact value of the charge is, anyone knows what is the exact value of the charge on electron? Any one of you know the charge on an electron? It is minus 1.60 into 10 to the power minus 19 coulomb. Minus 1.60 into 10 to the power minus 19 coulomb. Coulombs is a unit of charge, but we take this charge, which is 1.60 into 10 to the power minus 19 coulomb, to be a relative charge of 1, and it is minus, so minus 1 is given the charge to the electron. So electrons are negatively charged particles, and they have a charge of -1. I have just told you that they have a negligible mass compared to the mass of proton and neutrons, and it is 1 over 1840 of the mass of a proton. They are found in shells revolving around the nucleus. and they are represented by a symbol of E, and we can place a superscript as E minus just to show that they are negatively charged. So small e with a minus means electron. This charge is relative charge. The actual charge is in coulombs, which is minus 1.60 into 10 to the power minus 19 coulomb, but we are taking it to be the relative charge. Then comes neutron. Neutron carries no charge. They are neutral particles. They have a relative mass of 1. Actual mass is in kilograms, which is 10 to the power minus 27 kilograms. But these kilograms are then taken to be 1 as relative mass. Relative means compared to the mass of proton and electron. So if we take it to be 1, then the proton's mass is also compared to be 1, and the electron mass is 1840 of 1. So it carries no charge. It is found in the nucleus, in the center of the atom. It is the heavier particle, and it is represented by a symbol of just N. In some books, it is written as N raised to the power 0. 0 means no charge. Protons carries a charge of plus 1. Again, it is a relative charge. The value of the charge is same as that of electron, and it is not given in data booklet, but it is assumed that you should know. That is, the charge on electron is minus 1.60 into 10 to the power minus 19 coulomb. Then the charge on proton is plus. Charge on proton is plus 1.60 into 10 to the power minus 19 coulomb. It has a relative mass of 1. It means that its mass is in kilograms is 10 to the power minus 27 kilograms, and it is equal to the mass of the neutron, approximately the same. Slight change is there. Neutron is slightly heavier than proton, but on relative scale they are equal. On relative means we are comparing the mass of proton and neutron, and they are equal. They have same mass on relative scale, but the mass of electron is 1 over 1840. So it means that you have divided 1 by 1840, which is a very, very small value. Protons are also found in the nucleus, just like neutrons, and that makes the nucleus to be very heavy. And they are represented by a symbol P, small p, and we can have a superscript of P plus, so just to show that this is positively charged. Proton number and nucleon number, you know about these numbers. These are very important numbers given to an atom, and this numbers give us a whole information of the structure of an atom. So all atoms are electrically neutral. This is very important thing to know. If you know protons, you can know about electrons in an atom, or if you know electrons, you can know about protons, because number of protons and electrons are equal. If an atom has one proton, it must have one electron, so that plus one minus one cancels out to be neutral, zero charge. Neutron is already neutral. So an atom is electrically neutral if you pass an atom through an electric field. An atom through an electric field, it will pass straight through it. It will neither bend towards the positive terminal, nor it will bend to the negative terminal. It will pass straight through the electric field, and as it passes straight through the electric field, it shows that an atom is neutral. What is the reason behind the neutrality of an atom? The reason is that they have equal number of protons and electrons. So minus charge is equal to the positive charge, and then the net charge is zero. Proton number and nucleon number, very important number. How to define proton number, which is also called as atomic number. It is the number of protons in an atom, and that is called proton number. It is represented by a symbol of Z. So protons number also tells us the number of electrons in an atom, because the atom is neutral. So proton number not only tells us the number of protons, but it also tells us the number of electrons in an atom. For example, proton number of nitrogen is 7. So it means that there are 7 protons and 7 electrons. Different atoms have different proton numbers. Each element has a unique proton number, and that makes an identity of an element. No two elements have same proton number. So proton number is an identity of an element. For example, if you take carbon, it has 6 protons, and only any element, any atom which has 6 protons will be the atom of carbon element. It cannot be of oxygen or sulfur or iron or copper. If an atom has 6 protons, it is always carbon, only and only carbon. If an atom has 1 electron, it is only hydrogen. If it has 2 protons, it is only helium. If it has 3 protons, it is only lithium. So every element has a distinct atomic number or number of protons, and no other element can have the same number of protons. So it is a very distinct property of an element, of an atom, of an element. Nucleon number is the total number of protons and neutrons in an atom. It is represented by letter A, and nucleon number, by definition, its formula is it is equal to the number of protons and neutrons. And if you know the number of protons and if you know the number of nucleon, which is given in your data booklet in your periodic table, then you can find the number of neutrons by subtracting protons from nucleon number. So if you subtract protons from nucleon number, if you subtract protons from nucleon number, you will find the number of neutrons. Just a second. Okay, guys, we were studying about uh, nucleon number, and nucleon number is the mass number, and it is equal to nucleon number is the sum of number of protons and neutrons, and we have studied its letter is A. Nucleon number is also called mass number. It is also called atomic mass because the whole of the mass is found in protons and neutrons, and that's why nucleon number is also called the mass number. It is the mass of an atom of an element. How will we know that what number is proton number and what number is nucleon number or mass number? Your periodic table has elements in the form of their symbols, and every symbol has 2 numbers. One is subscript and the other is superscript. Subscript means जो symbol के नीचे लिखा होता है, और superscript जो symbol के ऊपर लिखा हुआ होता है. So the number which is smaller in number, or according to this, you see that Na is a chemical symbol. 23 is the nucleon number. 23 is the nucleon number. Nucleon number is the sum of number of protons and neutrons. And then proton number is written as a subscript below that of the symbol. But this is nucleon number. In your data booklet, this nucleon number might not be in whole number. And in modern periodic table, their placement has been changed. Now 23 will be written as a subscript and not as a superscript, and 11 will be written as a superscript. But the smaller number is always the proton number, and the larger number is always the mass number, nucleon number, or atomic mass. But in your new data booklet, in your new periodic table, when you are studying in A levels, these numbers, some of the elements will have the whole number in as oxygen is 16 or carbon is 12 and nitrogen is 14, sodium is 23. But many elements will have these numbers as like it can be 1.009, or it can be like 55.8 for iron, or copper can have a 64.2. So these will be in decimals. Why these will be in decimals, you will study in related classes. So this is the structure about atoms. Now we are going to study about isotopes. Isotopes. So from your knowledge of O levels, you know that isotopes are the atoms of the same element, atoms of the these are the atoms of the same element with same number of protons but different number of neutrons. So hydrogen atom, you see that it has purple color particle is 1 and it always remains 1. But in these three different atoms, the color of the blue, the green color particle is different. Its number is different. In one atom, it's none, 0. In one atom, it is 1. And in the other atom, it is 2. So these green particles are neutrons, and these purple particles are protons. Proton number is same, but neutron number is changing, and due to the change in neutron number, particles, the atom has different number of nucleons. One of them has one nucleon number because it has only one proton and zero neutron. Another atom has nucleon number to be 2, in which there is one proton and one neutron. And then the third atom has three nucleon number, which has one proton and two neutrons. So isotopes, they have same number of protons but different number of neutrons, and that makes a different number of nucleons. What is the definition of isotopes? According to the number, in terms of subatomic particles, these are the atoms of the same element. Please always start writing definition that these are atoms of the same element. Don't write that these are which have same protons, which have, what is the meaning of which have. Always start from atoms of the same element with same number of protons but different protons and electrons but different number of neutrons. So this is the definition of an isotope. So most of the elements are made up of isotopes. For example, chlorine, you know that it has two isotopes. One is chlorine 35 and the other is chlorine 37, and their relative percentage occurrence is 30. For 35 it is 75 and for 37 it is 25. And that's why since O level you are studying that the atomic mass of chlorine is 35.5. Atomic mass, relative atomic mass is 35.5, but their nucleon numbers are 35 or 37. Nucleon number is always in whole number, but relative atomic mass can be found by using a formula, and that can come in decimals as well. That's why when you see chlorine 17 35.5, 35.5 is not their nucleon number. It is the relative atomic mass in terms of atomic mass unit, in terms of relative, or it is the average atomic mass of chlorine, which is 35.5. So properties, if we know that the properties of an element are contributed by the electrons in the valence shell, electronic structure, and number of protons. So it means that they have same chemical properties because they have same electronic arrangement, they have same number of protons and electrons, but their physical properties differ, such as their densities, their melting points, their boiling points. These differ because density is dependent on the mass. So many of these isotopes are radioisotopes. For example, carbon 14 is used in carbon dating. Then plutonium 238 is used as a pacemaker, and it is implanted in heart to regulate the beating of the heart. And then there are other elements such as cobalt 60, which is used to kill or cure cancer. So today we have studied about atomic structure and structure of an atom, as well as we have studied about isotopes. So